Okay, let's go to the security aspects of the consumer devices ecosystem. We'll talk about the certification policy, certificates, keys, and the algorithms. Yes, for the keys, there's a public key infrastructure is used, the PKI. It is defined in the SGP 14. So there's GSMA EOSC public key certificate policy document. And this policy document is used. So this is a very general description. So it's not a technical document. So it does not describe how the certificates, procedures, and the security is working, but it might be useful depending on your use case. The aim of the SGP 14 is to define the policies by which the USSC PKI will be governed by the USSC PKI Policy Authority. It describes the establishment and maintenance of an efficient and effective end-to-end trust infrastructure within the ecosystem. For the EUSSC and servers defined by GSMA for remote provisioning, an EUSSC PKI to support the use of certificate for authentication has been defined. Mobile network operators relying on the EUSSC PKI need to be able to determine the degree of trust which can be placed in the authenticity and integrity of the certificates issued by the certification authority, the CA. Information upon which such determination can be made is documented here in the GSMA UCC PKI certificate policy. The certificate policy for the GSMA PKI is consistent with the Internet X509 PKI certificate policy and the certification practices framework. It governs the operations of the PKI components by all individuals and entities within the infrastructure. It provides the requirements that PKI participants are required to meet when issuing and managing certification authorities, certificates, and private keys. Okay, this is the general set of the requirements, actually. And additionally, it informs potential relying parties about what they need to know prior to relying on the issued certificates. So in general, it describes the overall business, legal, and technical infrastructure of the GSMA PKI. Let's go to the certificates. There is a certificates hierarchy used for the consumer devices. It's a different one than for the M2M one. But again, we will have the GSMA root certificate, another one for the consumer than for M2M. This is a trust anchor inside of the EUSSC or the subscription manager used to verify the validity of the other subscription manager or the EUSSC manufacturer certificate. The GSMA CI issues the certificates for the SMDP Plus and the SMDS. So these certificates are used for the authentication. They are called certificate DP out CDSA, or the DS out CDSA. This is the server certificate used for the authentication. With its corresponding private key will be stored on the server side in the secure part, and the public key can be made available for this authentication purposes only. So as you probably can already guess, so these certificates will be issued only to the parties which are certified according to the GSMA procedures. Additionally, for the profile download itself and for the profile binding, the DPPB certificate is used. So this certificate is used for the actual key establishment procedure. And yes, using this certificate, this new keys can be derived and used in this symmetric protocol. Additionally, the SMDP Plus and the SMDS will have the TLS certificates. You remember there is this HTTPS channel established, and for this you will need the server certificates. There are no device certificates, so there will be only one side of this authentication inside of the TLS for this. For the EUSSC, so first of all, so the GSMA issues the EUM certificates, and then the EUM issues the EUSSC certificate itself. They are used for the client authentication. Let's take a look on the profile download server authentication part. For this, we have this SMDP Plus with different types of certificates. The server authentication part relevant is the DP out ECDSA, and then there's this PB part and the TLS part. And for the verification, so the LPA will have this trust anchor, so the certificate CI CDSA, and the USSC will have the certificate CI CDSA here. So the root GSMA CI certificate pre-installed and in the device. Yes, first for this TLS channel establishment, the TLS certificate will be sent to the LPA. The LPA verifies the certificate using the GSMA CI, and if it's authentic, so then the channel can be established. And the next step, so there is a negotiation required. So the EUSSC will inform. So now the EUSSC is involved, and the EUSSC inform the SMDP Plus about the list of possible certificates which can be used for verification and signing. So this list is this EUSSC CI public key ID list for verification, EUSSC CI public key ID list for signing. And so it will contain the CI public key ID. Okay, the server decides which public key ID is to be used, selects one, and informs the EUSSC. And then according to the selection, it sends the authentication certificate so that EUSSC can verify the specific certificate. So for example, it can be the case that EUSSC is using different types of elliptic curves, so different types of CIs. So they're not the brain pool curves or the NIST curves, and then it's informing the SMDP Plus, hey, I have only the NIST curves there, so or this specific curve, and then please send me this part. And the server can select from the pool so which certificate to use for the verification. Okay, in the next step, it's not authentication anymore, but so for the specific part of the key establishment, you can call it authentication as well. But this is a part when the server delivers the PB certificate for the key establishment process. And if everything is fine, so the next step can be performed. So the authenticate client part, actually after the authenticate server part, so after the exchanging of the auth certificate. For this, remember that SMDP Plus has this CI certificate on it as a trust anchor. And the EUSSC, the EUM certificate and the EUSSC certificate. Okay, the HTTPS channel is established. So, but then these two certificates would be delivered to the SMDP Plus and verified by this GSMA CI certificate. And then the actual key establishment can be performed with the specific ephemeral keys, temporary keys, being generated on the SMDP Plus. We have this key pair for the so the DP OTP key, DP elliptic curves key agreement, and difficult names. And on the same side, the EUSSC ephemeral key pair. Okay, here we have this two keys, and this for the server side, and they are exchanging the public keys. The public keys will be exchanged in HTTPS in the JSON format. So actually all of the data will be on the server side, so will be performed using JSON. So between the server and the device. but not on the server and not between the device and the EUSSC part. Okay. After the SMDP Plus receives the public key of the EUSSC, just take a look once again. So it uses these two keys, its own secret key and the EUSSC's public key to derive the shared secret. And from the shared secret, so the symmetric keys can be derived for the SCP-03T. In the same way, the EUSSC can use the public key of the SMDP Plus and its own secret key to derive the shared secret and then the symmetric keys. Yes, as soon as the keys are there, so then the secure channel can be established, SCP-03T, Secure Channel Protocol 03T, defined by a global platform. The profile can be secured, and the profile will, with all of its data, file system, and network access keys and applets, security domains can be used. Let's take a look on the cryptographic information once again. As you could see already, so there is this EC before the name of the algorithm, not the algorithm, the procedure actually. And so it stands for the elliptic curves. The elliptic curves are used as a brain pool curves, NIS curves, and FRP curves with 256 bits. The SCP-03T, what is behind? So this is actually the AES in CBC mode with a key length of 128 bits, referred as ESC 128, with CMAC and C decryption. The SCP-11A protocol, which is used for the key establishment, is defined in the Global Platform Amendment F. Let's take a look there. Okay, let's go to the JSON binding. JSON stands for the JavaScript object notation and is a lightweight data interchange format. The HTTP request will be sent as using HTTP requests, and inside of this HTTP request you will see there is the server address, the user agent data, and then the protocol using the version of the RSP specifications. Then the response header, you will see the status code, if it was successful, again the version and the other information, actually the messages itself, length. The message, so the JSON message, as an example, can be like this, so that for the example, for the EUSSC challenge, at the very beginning of the procedure of the profile download, you will have the EUSSC challenge, EUSSC info 1, and yes, SMDP address. These are just some examples. Okay, so this cryptographic part, the content actually of the procedure itself, so the functions will be there. Okay, that's all very quick about the security. Please take a look, take your time to go deeper in this topic and to go one by one. So there's one point to mention. There's another type of structures used. It's the ASN1. This is the description of some data object in their RSP specifications based on ASN1, which is specified in X680 and encoded in the TLV structures using the distinguished encoding rules. And the specifications, this is all given. So ASN1 structures are well used in this all exchange of the data format. So especially towards the EUSSC, it will be used the ASN1 structures. But the EUSSC is not mandated to analyze the character structure of the strings provided in the command. So there are some strings, some format, and so it can be the case that the strings contain some error. So and the LPA should take care of possible errors into account. And the definitions of the ASN1 data objects may differ between the different versions of the SGP22. And especially some fields may be marked as optional, and there might be some additional fields added to the specific definition of the data object. So please be careful with this and take a closer look on the definitions, because they might differ but even between the minor versions. Okay, that's all for the security part. And let's summarize or verify your knowledge, so you can take a closer look on this, and especially, so by answering these questions. So for example, how many certificates are used in the consumer devices architecture? It's a little bit more than in the M2M world. But don't worry, so you will have even more in the next versions of the specifications, the version 3. So please get familiar with this topic in this case, if you're because you need to be prepared for the version 3 of the specification. What is indicated in the EUSSC CI PKID list for verification? Okay, you can take a look on this, the specific definitions, or you can guess already from the name. Which protocol is used for the profile encryption? Okay, for the actual encryption, there's one protocol is used. For the key establishment, another protocol is used if you go on the secure channel protocols or the SCP level. Okay, which interfaces are using JSON? Mentioned this. You can select them by names, or you can give a very general answer. I think I was more general. So don't worry, and please read the specifications for this part. That's all from my side. Let's summarize. So we assumed the basic knowledge of the consumer device architecture, the profile types. We talked about the RSP procedures and the security aspects. And in the next step, I recommend you to take a look on the international standards. So what is the current standard? And the certification part. So what is required to certify your product and to receive the certificate from the GSMA to be the full participant of the ecosystem. Okay. Hope to see you soon, or see you again in some other videos. You can see me. I cannot see you. Thank you very much for your attention, and goodbye.